In this video, we are going to start one of the important topics in mathematics, which is the part of our basics mathematics, inequalities. So in this video, we'll discuss what exactly the meaning of inequalities and how we can solve the inequality. But before going to start the inequality, it is important to know what exactly the meaning of intervals and unions of intervals and intersections of intervals. So now to understand the intervals, let me just give you an idea of a number system that you might know, like natural number, integers, whole numbers, rational number and real number. These all numbers having some kind of representations. So intervals is also one kind of representations of real number between any two given real number. So let me just give you the quick recap of the natural numbers collections. Like you might have know this all these things, like natural numbers collection will denote it by capital N. So it's nothing but collection of all natural number 1, 2, 3, 4 and so on. Likewise, we have a notation for representing the collection of whole number by W, which is 0, 1, 2, 3 and so on. And for integers, we have a notation I or C, which will denote collection of all the integers. So negative infinity to negative 2, negative 1, 0, 1, 2 and up to positive infinity. So like that we have a notation for representation of a rational number, which is Q, which is nothing but collection of all number of the form P by Q, where P, Q both are integers but Q not equal to 0. So, and we have representations of irrational number, which is all number of the form a square root of x, where x is non-perfect square number, non-perfect square. So these all are the notations of numbers that we have learned till now, and R will denote it by real number, which is exactly the union of rational and irrational. So if you are not familiar with union for now, so just you can consider this as it is nothing but whole of these you like rational as well as irrational. By combining the rational and irrational, we'll get a real number. So these all are the representations of basic number system that we have. Now if we talk about the real number, so number line, if you look into the number line, so this number line will represent all the numbers from negative infinity to positive infinity. So actually this line is representing the whole real number. So here, if you look into this, if we are taking any one point over here, one number over here, let's say 2, and here let's say 3. So between these two numbers, you can find that there are infinite numbers. There are many numbers are there. So on a number line, if you think of, okay, if you have any two numbers, then between that you can find infinite numbers of real number between that. So here, this intervals is nothing but it's a real number between given two real number. So for example, if I'm writing this as, okay, we are looking for, we have a point 2 and 5 over here. Now if we are going to represent, okay, what all point lying between 2 and 5, so for that we'll use the method of representation that we call as intervals. So let's see, the first kind of interval that we have is open interval. So the first interval is open interval. Open interval means if we have given any two real numbers and we are looking for all the values of real number between those 2 points, in which the 2 point will not be included. For example, if we are writing, okay, open interval means the values of all x which is less than b and greater than a. So those values of x which lies between a and b but not equal to a and not equal to b, that we call as open interval, that we can write in this way, like less than symbol will use for, okay, values of a to be less than x and values of x less than b, which can be represented in the form of like a comma b. Open interval means we'll use this parenthesis for representing the open interval AB. It means what? On a number line, if you look for the point A and B, so here this open interval AB means all the values of x between A and B, but except this point A and point B, all the values of the real number will come between A and B except 2 and 3. So here, if we are looking for any number, let's say we have 1 and 2. So this open interval 1 comma 2 is nothing but values of all real number between 1 and 2 except 1 and 2. It means in this interval the values of x will be either 1.1, 1.001, any number, just write of it any number. If you are looking, that will be nothing but included in this interval, but the x is equal to 1 is not included in this. The same way x is equal to 2 is also not included in this. So this open interval says that a point of all real number between a and b except a and b. This can also be written as this way, inverted close bracket a comma b, and over here also inverted close bracket. So this is open intervals AB. Now the second type of interval is closed interval. Closed intervals means it is set of all values of x lying between a and b, in which a as well as b both are included, which we can represent it as closed interval means box bracket a comma b. So it says that x is belonging from a to b. It means we are having all the values from a to b, in which a and b both should be included. If the point is included, we'll take it as a shaded circle. Okay, means shaded circle means it will indicate that the point a is included and point b is also included in this interval. And here hollow circle means it will denote that this particular point is not included in this collections of numbers. So this is the second type of interval. Now we have the third type of interval, which is open closed interval. Third type is open closed interval. So open and then closed means left side is open, right side is closed. It means all values of x which is less than or equal to b but greater than a. This we can denote it as a comma b, closed at the end of b. So if we are trying to understand it on a number line, it means it should be like this. Hollow over here. This is hollow. And this is dark circle. So all the point between this to this, here this point A is not included, but this point B is included. This is open close interval. And the fourth interval is closed open interval. Closed open means left side closed, right side open, means set of all values of x for which x is either equal to a or greater than a but less than b, which we can write in a interval notation as close interval a comma open at the end of b. So we can write this on the number line like this. So a comma b means set of all values in which between a and b in which a is included but b is not included. So these are the four type of intervals we have. We'll mostly come up with these intervals while dealing with the inequalities. But one more thing that we need to understand is union and intersections. So let me just give you an example over here. So suppose we have given an interval over here 2, 3, 4 and 5. So over here we have given one interval as, okay, we have given one interval as 2 to 4, where open at 2 and closed at 4. It means we have given interval 2 comma 4, and we have given another interval which is 3 comma 5 open at 5. So we have two intervals, two comma 4 and 3 comma 5. If we talk about, let's say I'm writing this as interval I1 and this as interval I2. If we talk about union, so union means like collection, union of two interval, or if we talk about union of two intervals, it means it is the intervals which contain both the intervals. So if we talk about this example, interval I1 and I2, so I1 is from 2 to 4 and I2 is from 3 to 5. So the union of these two is I1 union. This symbol U is for union. I2 is nothing but an interval which contain this interval as well as this interval, right? So if you look into this, it is nothing from 2 to 4 and this is from 3 to 5. So if you look into this, okay, 2 to 4 and 3 to 5, this all are coming between 2 and 5 are not. So it means union of these 2 point is to these two interval is nothing but interval 2 comma 5. Here as 2 is open over here, so we need to keep open at this end, and 5 is also open, so we need to keep open bracket over here. So the union of this interval 2 comma 4 and 3 comma 5 is interval 2 comma 5, where both 2 and 5 are open. But if we talk about the intersections of these two, then intersection is nothing but the common in both the intervals. So if you look common in both the intervals, you can find that, okay, this interval I1 is from 2 to 4 and this interval I2 is from 3 to 5. So in this, we have this region which is common in both. So as well as you can find that this 3 is included and 4 is also included. So the intersection of these two, I1, and we'll use the inverted U for the intersection symbol. I1, I2 is nothing but interval containing 3 and 4. Okay, 3 and 4, this is the common region. But here 3 is also included, 4 is also included. So we need to keep the closed interval at both ends. So, okay, so let me just give one more example for better understanding of union and intersections of the intervals. Okay. So suppose we have given an interval I1 is equal to 3 comma 7, open at 3 and closed at 7, and we have given another interval which is -2 closed at -2 and open at 5. So if we look about the union of these two, means I1 union I2. So the direct way without like trying the intervals, we can look into this. Okay, so left side of the intervals, both the left side of the point of both intervals, we have to look which one is smaller in these two. So you can find that, okay, so here 3 and this is -2. So -2 is on the left of 3. It means if we are taking any values which is greater than -2, that will contain 3. So see, it is nothing but -2 over here, okay, and 5 over here, 7 over here, and 3 over here. So first interval, if you see, this is from 3 to 7, open at 3 and closed at 7. So this is 3 to 7. And second interval is from -2 to 5. -2 is included. -2 to 5. Here 5 is not included. Now if you look into the union of this, it means that interval which contain both this interval as well as this interval is nothing but from -2 to 7. So -2 is closed over here, so we need to just write the close bracket at the left side, as well as this 7 is also closed, so we have to use the closed interval. So union of these two interval is -2 to 7. But if we talk about the intersection of these two, then we need to look for the common values in these two intervals. So if we see the values over here, which is common in all, is nothing but here to here. It means between 3 and 5. As here 3 is not included, 5 is also not included, so it will come as open interval 3 comma 5. So this is very important like things that we must have to understand before dealing with the inequalities. So like we have just discussed the what exactly the meaning of intervals. We have seen 4 types of intervals. Open intervals means both end will be not included. Closed interval means both end will be included. Open closed means left is open, right is closed, and closed open means left is closed and right is open. And apart from this, we discussed the union. Union means that real numbers which contain both the intervals, and intersection means between the two intervals, the intersection is the common part of those two intervals. So let's now start these inequalities. So inequalities, if we are going to define, then it's just like an equation, right? So but there is a difference in the word equations and inequations. Both are nothing but comparisons of expressions. If we are just giving the example of an equations, so let's say we have something written as 2x plus 4 is equal to x minus 4. So you all are familiar with this. This is an equations. So here this is an expression and this is also an expression which are compared with the symbol equal to. That's why we are calling this as an equation. So when you talk about the inequalities, so this is also the comparison of two expressions, but instead of equality symbols, it is compared with either greater than symbol or less than symbol or greater than equal to symbol or less than equal to symbol. So for example, if I'm writing 2x plus 4 greater than 3. So this on the left we have 2x plus 4 which is an expression, and on the right we have 3 which is also an expression, and we compare this two expression with greater than equality, greater than symbols. So because of this is nothing but inequality. Another example you can see, if we have 2 plus x less than 5, here also two expression is compared with less than symbol, so this is also an inequality, or we can sometimes call this as inequation also. Either expression is compared by less than symbol, greater than symbol, less than symbol, or it is compared with less than equal to symbol. Or here you can find it as, let's say 4x square plus 5 is greater than equal to 7. So here the two expression is compared with greater than equal to symbol. So this particular thing we call it as inequations. So now before going to start with like getting how to solve this kind of inequality, like we used to solve the equations, means solving of equation means we are looking for the values of x which can satisfy this equation. The same way when we talk about the like solution of inequations means we are looking for the values of x which can satisfy this all inequalities. So before going to start with the method of solving the inequalities, we must have to understand some of the basic properties of the inequalities. So let me just start with one example over here. See here, I have written some of the result over here. You can find that if we have an inequality a less than b, then if you are adding both side or subtracting both side by the same quantity, then there is no change in the inequality symbols, but the condition is the quantity that we are adding should not be 0. For example, if we have given an inequality 2 less than 3, 2 less than 3, if we are going to add 5 both side, so if we are going to add 5 both side means 3 plus 5 and 2 plus 5, 2 plus 5 is 7, 3 plus 5 is 8. So again we are getting that 7 less than 8, means by adding this 5 on both side of the inequality doesn't change the sign of the inequality. So this is the first properties of inequality, which says that by adding or subtracting the same quantity on both sides of the inequality does not change the sign of the inequality. You can see another example. Let's say we have given x plus 5 or just x, let me just take a numerical figure, let's say 5 less than 9, and if you are going to subtract same quantity both side, let's say I'm subtracting 7 both side, so here 5 minus 7 is minus 2 and minus 9 minus 7 is 2, so here minus 2 is less than 2. Okay, so here you can find that 5 less than 9, by subtracting the same quantity on the both side, so whatever be the result we are getting, that is also satisfying the same inequality. We found that there is no change in the inequality over here. So we just need to like keep it in mind that this result which we'll use in solving the inequalities. So by adding and subtracting same quantity on either sides of the inequality does not change the sign of inequality. This is the first like elementary properties. Now second elementary properties, if you see over here, is we have a less than b, and we are multiplying both sides by the same quantity k, and it does not alter the sign of the inequality. It is only the case that if k is positive, if this value, whatever with the value we are multiplying, is positive, then the inequality sign will not alter. Means if we multiply either side of the inequality with a positive number, then the inequality sign will not alter. But if the c in this case, if the value of k is negative, then it will alter the sign of the inequality. For example, let's say we have given 2 less than 5, and if you're going to multiply both side of this inequality by any positive number, let's say 7. So if you multiply 2 by 7 and also 5 by 7, so you will get 14, and here you will get 35. So you can find that 14 is less than 35. So when we multiplied the either side of this inequality with the non-negative values, non-zero non-negative values over here, we got the result which is having the same inequality symbol. But if we are going to multiply this by negative number, let's say I'm taking -3. So if you multiply 2 by -3 and 5 by -3, so we'll get 2 into -3 is -6, and here -15. Here you can find that the -6 is bigger than -15. So you can point out over here that when you multiply this inequality by a negative number, then it alters the sign. Means if a sign is less than and you are multiplied with negative number, in the result you will find that the sign will be reversed to the greater sign. So this is the second very important like elementary properties of an inequality. The third one is like the same way. If you are going to divide the inequality by a positive number, then it won't alter the sign. Same example I'm taking over here, 2 less than 5. If we are going to divide both sides by a positive number, let's say k is equal to 2, then you can find that 2 divided by 2 and 5 divided by 2, 2 divided by 2 is 1, 5 divided by 2 is 2.5. Here 2.5 is greater than 1. So by multiplying this either side of the inequality by a positive number, we got some result without interchanging the sign of the inequality. Means if you divide by a positive number on either side of the inequality, it does not alter the sign of inequality. The same example you take over here, and in that case now try to divide it by -2. So 2 divided by -2 and 5 divided by -2. 2 divided by -2 is -1, and this is -2.5. Here -1 is bigger than -2.5. So here we found that the inequality sign is altered. So we found that when an inequality is divided by a negative sign, then it will alter the sign, and if it is divided by positive sign, then it won't alter the sign. So this is the third very important result in elementary properties of an inequality. Now let me discuss few more properties, then we'll move to some examples. Okay, let me just erase this part over here. Okay, now if we have an inequality A less than B and B less than C, then we'll get that this A will be less than C. This we call as transitive property. Transitive property. So here, for example, if we see like 2 less than 4 and 4 less than 7, so it is obvious that 2 is less than 7. Okay, so this we call as transitive property of an inequality. The same way, if we have like in the same thing, like if A less than B and B less than or equal to C. So one thing you have to keep it in mind, this symbol less than or equal to. Both will not come together. It will come either less than or equal to. So here we have A less than B and B less than equal to C. Then by the transitive property, we'll get that A less than or equal to A less than B and B less than equal to C. So for example, you can just check it like 2 less than 4 and 4 less than or equal to, let's say, X. So we can write by using the transitive property as 4 less than equal to X and 2 greater than 2 less than 4. Now we have few more result on this. Wait a moment. Okay, why this is happening? Okay, now this is also very important result. So if A less than B and B is greater than C. So in this case, A less than B, B is greater than C, then there is no relation between A and C. Then there is no direct relation between A and C. See, for example, let me just take a number line. Over here, I have taken a 5, which is greater than 3, and 5, which is bigger than 4. So here, the first thing I have taken is 5 greater than 3. 5 is greater than 3. And the second thing that I have taken is 4 is less than 5. 4 less than 5. Then we can't find any direct relation between 3 and 4. So let's see how we can get it. So now we are going to discuss the elementary properties of inequalities. So these property will help you in simplifying the inequalities. So let me just give you the very first property, which it says that suppose we have given an inequality a less than b, and if you are going to like add both side of the inequality by same number, then the sign of the inequality will not change. For example, let's say I'm adding a number k on either side of this inequality, then we'll get a plus k, and on the right side we'll get b plus k. So in that case, the sign of the inequality does not hamper, means it will be as it is. If it is less than, then this will be less than. Or if we have a greater than b and we are adding the same quantity on either side, then sign of inequality does not change. Or it is greater than equal to, then the inequality sign does not change by adding the same quantity on either side. For example, let's say if I'm taking an inequality 2 less than 3, if you are going to take k is equal to 4, adding 4 on either side, so we'll get 2 plus 4 as 6, 3 plus 4 as 7. Now here 6 is less than 7, so initially we have the inequality symbol is less than. By adding 4 on either side, the result is also having the same inequality. Likewise, instead of adding, if we are subtracting also by same quantity on either side, then the inequality symbol does not change. See an example over here. Let's say we have given minus 5 less than 7, and if we are going to subtract 5 from both side, so let me subtract 5 from both side. So minus 5 and 7 minus 5. So minus 5 is minus 10 and 7 minus 5 is 2. Here 2 is bigger than 7. So by doing the same operation on both sides, we got an inequality with the same sign. So just keep it in mind, like whenever we are doing additions or subtractions on either side of the inequality by the same quantity, then it does not change the sign of the inequality. The very important result over here is if we are multiplying or dividing either side of the inequality, then it is important that by which number we are multiplying or dividing. Based on that, the sign of the inequality will change. So here, if we have an inequality a less than b, and if we are multiplying by a number, let's say k on either side, so ka and this is kb, then the sign will not change if the value of k which we are going to take is positive. If k is positive. If we are multiplying either side of the inequality by a positive number, then the inequality sign does not change. The same is applicable for division. If we are dividing either side of the inequality by the same positive number, then the inequality sign does not change. Here a is less than b, then a by k is also less than b by k if k is positive. For example, if we have 5 less than 7 and we are multiplying both sides by, let's say, 5, so 5 into 5 and here 7 into 5, so that will give us 25 and 35. Here 35 is bigger than 25, so we can see that the initially we have the inequalities of less than type. By multiplying either side by the positive number, we got some result which is having the same inequality. The same is applicable for division also. 5 less than 7, when we divide it by 5 either side, 5 by 5 and 7 by 5, so 5 by 5 is 1, and this is something like 5 1 the 5, then 0.4, 1.4, right? So 1.4 is obviously greater than 1. So here also we have seen that upon division by the same positive quantity, here the key thing is what number we have divided, 5, which is positive. That's why the inequality sign does not change. What if the sign is negative? If the value of k is negative in either of the case, whether you are going to multiply or going to divide, then the sign of the inequality will change. For example, if I'm going to take 2 less than or less than 7, and now I'm going to multiply this either side by 3, -3. So -3 into 2 and -3 into 7. -3 into 2 is -6 and this is -21. So among these two, the negative number with the least numerical figure is bigger, right? So here -6 is bigger than -21. So here the result is having an greater than type of inequality, while in the initial we have less than type of inequality. So when we multiplied either side of the inequality by a negative sign, then we must have to revert the sign from less than to greater than. The same is applicable for division. So if we have given 5 less than 7 and we are dividing by -2, then we must have to reverse the sign from less than to greater than, less than to greater than type. Okay, so this is the two very important result in the basic elementary properties of inequality. Apart from this, we have one more very important inequality, which is the third inequality. Suppose we have a number a which is less than b and this is positive. Now if you are going to take any power on either side of this inequality, let's say I'm going to take power r over here. So we have a less than b. If we are going to take power r on either side, then the inequality sign will not change if the power is positive number. So this inequality less than type will not change if the power that we have taken is positive, if r is positive. But if this r is negative number, then the power sign will change. See, first take an example over here. We have given 2 less than 3, and if you're going to take the power, positive power of 2, let's say I'm taking -2 over here, and over here also, sorry, let's say I'm taking +2 over here, and here also +2, then 2 square is 9 less than, sorry, 2 square is 4 less than 3 square 9. So this is true, means while you are performing the positive power of inequality, then there won't be any change in the symbol of inequality. But if you're going to take negative power, let's say instead of taking 2, I'm taking -1. So 2 to power -1 means this is 1 by 2, and 3 to power -1 means this is 1 by 3. So this is bigger than 1 upon 3. So here initially the inequality is of less than type. Once we have taken negative powers on either side, then the inequality symbol has reversed. So the thing is, this thing is very important to keep it in mind. Means if a less than equal to b, then a to power r greater than equal to b to power r if r is negative. So this is the very important result in elementary operations or properties of inequality. Few more are there, but those are not that much important. So let me just take the next a property, which is, let's say if we have given a less than b and we have given b less than c, means we have two different inequality and in which one of the point is common, then we can say that we have a relation between a and c and this a should be less than c. So we can understand it with the number line also. Let's say here we have a, here we have b, and here we have c. Now here a is less than b and b is less than c, then obviously this point a is less than this point c. So this property, like a less than b and b less than c, means a is less than c, that we call as transitive property of inequality. Transitive property. Now we have a few more things over here, like a less than b and c less than d. We have two inequality, so we can add these two inequality like this sidewise, means if both inequalities of same sign, means less than type, so we can add it as a plus c less than b plus d. A plus c less than b plus d. Okay. Now this result, let's say a less than b and we have b greater than c. So if a less than b and b greater than c, here this inequality is not same, then we can't find any relation between a and c. We can't find relation between a and c. A and c. So let's see why we can't find a relation between a and c. See, suppose here what we have, a less than b, means let's say a less than c, means I'm taking a as 4, b as 5. Okay, so a less than b. Now b is greater than c, so c might be, let's say this is 3, this is 3. So here a is 3 and b is 5. This is b, this is a. Now the value of b is bigger than c, so c is either 4 or c is either 3 or c is either 2, any number which is like b is greater than c, so c might be any smaller than 5. So it might be 4, it might be 3, it might be 2, or it might be any negative number. So because of this reason we can't say what exactly the value of c is, so we can't like connect between a and c, so we can't find the relation between a and c if the two inequalities are of different sign. Then like even though this is common in both, but we can't find the relation between a and c as in the previous case, like the transitive property. Okay, so we'll use all this property in solving the inequalities. So let's see, I have taken some basic example over here. Then by doing this we'll able to use the basic properties, and then we'll use this understanding of like simplification of inequalities for solving the some different kind of inequalities. So let's see, first example we have given as 5x less than 15. It means we need to look for the solution of this. Solution of this means we have to find the values of x which can satisfy this. So one thing, keep it in mind, like in equation like linear equation, we have one solution. Quadratic equation we have two solution. But if it comes to inequality, then inequality solution will have infinite solutions. So let's see how we can solve this kind of inequality. So here 5x is less than equal to 15. So like we need to find the values of x, means we'll try to isolate x over here and remove all the numbers from this side. So here, as 5 is in multiplication, if we want to omit this 5, we can divide this by 5. So again on other side also we can divide by 5. So if we divide both side by positive number, means inequality sign that does not change, right? So as we have seen that a less than b, and if we are dividing by same constant on either side, both the constants are positive, then this inequality sign will not change. With the help of this, we can solve this one, like 5x less than equal to 15. So by dividing 5 both side, we'll get over here x less than equal to 3. So the solution for this inequality is all values of x which is either 3 or less than 3. So we can write in terms of interval as x belongs to less than 3. Less than 3 means either of the values, either zeros or any negative number, even -5, -7, whatever be as smaller than that, means will have infinite negative values, right? So it will be nothing but minus infinity to 3. Now let's come to solve these questions. Here we have 5x plus 27 less than 2. So we are trying to find the values of x. So we'll try to isolate x on the left side, and we'll like omit all the number from left. So for that, what we need to do is just here, this is plus 27. If we want to omit this, we need to subtract 27 here as well as here. So we'll get 5x plus 27 minus 27 and 2 minus 27. So I have subtracted both side by minus 27. So this inequality sign will not change. So here plus 27 minus 27 will cancel. So we'll left with 5x on the left, and on the right side we left with minus 25. Now here we want to like isolate x, means 5 is in multiplication. So we'll divide both side by 5. So that will give us x less than minus 5. Means the solution of this is all values of x which is less than minus 5. Less than minus 5 means minus 5 over here, and all the values of x which is less than that. So here, as this is less than only, so this point will not be included. So we can write it as x belongs to minus infinity to minus 5. Now, so here we have 7 minus 4x greater than minus 17. So we want the solution for this. So what we'll do is to isolate x over here. So for that, we need to just remove all the other numbers. So here this is plus 7. To omit this plus 7, we have to subtract 7 on both side. So minus 17 minus 7, by subtracting same number on either side does not change the inequality side. By doing that, we are able to eliminate 7. Now we left with minus 4x, and on the right side minus 17, and minus 4 is minus 24. Now we are going to eliminate this minus 4 from the left. So here what we are going to do to isolate x, we are dividing by 4, negative 4. So while dividing by negative numbers means inequality sign will reverse. So here we have minus 4x, and we are dividing it by minus 4. So this inequality sign will change. The same thing we have to perform on either side. So here minus 4 cancelled. So x less than minus cancelled. This is 6. So the values of x is less than 6. So we can write in terms of interval as minus infinity to 6. Open over here, because this point is not included. Now, to see this example, now here 6x plus 8 less than equal to 7x minus 9. So here variables on either side of the inequality. So we want to isolate the variables. So first thing what we'll do is we'll move this 8 to either side by, like here 8 is in plus, so by subtracting 8 from left as well as right, that will eliminate 8 over here. So this is 6x plus 8, so minus 8 less than equal to 7x minus 9 minus 8. So while we subtracted with the same quantity on either side, the inequality sign will not change, but because of doing this we are able to eliminate 8 from the left. Now we're left with 6x less than equal to 7x minus of 17. Now we want x on the either side of the inequality. So on the right side we have 7x as well as on the left side. So what we'll do is we'll eliminate 7x from right. So for that we have to subtract 7x over here as well as on the left side. So 6x minus 7x less than equal to 7x minus 17 minus 7x. This minus 7x plus 7x cancelled, and here 6x minus 7x is minus x less than equal to minus 17. Now here we got the values of minus x, but we are looking for the values of x, so we'll divide both sides by minus 1. So why dividing the inequality by negative sign, we must have to reverse this sign. So x divided by minus 1. So here this number is negative, so this inequality sign should be reversed. So negative 17 by negative 1. So here this is x greater than equal to negative cancelled, so 17. It means the values of x over here is nothing but either 17 or bigger than that. It means x belongs to closed interval because this is equal to, so closed interval 17 to infinity. Make sure always put open interval at plus infinity or minus infinity end. Now, so here in this question we have given minus 3 less than equal to 2x minus 3 by 5, and on the right side, okay, so here let's say this is 3. So we want to solve this inequality, but here in this we have two inequalities. Here minus 3 is less than 2x minus 3 by 5, and this 2x minus 3 by 5 is less than equal to 3. So we can do this in two ways, by splitting this inequality in two inequality. Let's say, let me do with the first method, like this can be written as 3 less than equal to 2x minus 3 divided by 5. This is one of the inequality, and second inequality is 2x minus 3 by 5 less than equal to 3. So we have to solve this inequality and this inequality separately, and like at the end we have to look for the common in both. Okay, so just go for this. Like here we have minus 3, so let me solve the first part. Minus 3 less than equal to 2x minus 3 divided by 5. So to omit this 5, what we'll do is we'll multiply both sides by 5. So minus 3 into 5 less than equal to 2x minus 3 divided by 5. If we multiply it by 5, this 5 cancelled, and on the left we have negative 15 less than equal to 2x minus 3. Now we are looking for x value, so we'll eliminate this. So for eliminating this 3, we have to add 3 here as well as here. So once you do that, you'll get negative 15 plus 3 is negative 12, and this is less than equal to 2x because minus 3 plus 3 is 0. So we're left with 2x. Now to eliminate 2, we have to divide both sides by 2, as these two are positive number, right? So there is no change in the inequality. That will give minus 6 is less than equal to x. Means x value is nothing but bigger than minus 6. So you can write it as like this, minus 6. Okay, here we got the values of x to be bigger than minus 6. This we got from this part. Now we have to solve this part also. Once we are going to solve this part, we have 2x minus 3 divided by 5 less than equal to 3. So to isolate x, so what all additional things over here will try to eliminate this 5 which is in denominator. So we have to multiply both sides by 5. So 2x minus 3 by 5 multiplied by 5. So multiplied by 5, as we multiply by the positive number, so that there is no change in the inequality sign, so these two got cancelled. So we left with 2x minus 3 less than equal to 15. So here we want to like eliminate 3, so we need to add 3 here as well as here, means we'll have with 2x less than equal to 18. We added 3 means minus 3 plus 3 is 0 and 15 plus 3 is 18. Now to eliminate this 2 from here, we have to divide both sides by 2. So as both are positive, so there is no change in the inequality, means this will give us the value of x to be less than 9. So here we got the value of x to be bigger than minus 6, and here we got the values of x to be like less than 9. So we have to look for the common in both. So if you are plotting this on a number line, then you can able to visualize what values of x will come as a solution for this one. So let me just take a line. Okay, I have taken a line. On this line, for the first part, it says that the values of x will be greater than minus 6. So here, let's say I'm taking minus 6 over here. Here this is minus 6. Minus 6, as this is equal to also, it means the values of x is all values including minus 6 are greater than this. Okay, now from here it says that all values less than 9. Okay, let me take 9 over here. All values less than this means less than this. Okay, it means by looking into this 2, we can find it. Okay, values of x is bigger than minus 9, minus 6 and less than minus 9. It means for these two regions, which is the common region, this and this, it means minus 6 to 9. So the solution for this is nothing but x is less than 9, less than equal to 9 or bigger than equal to minus 6, which we can write it as x belongs to minus 6 to 9. This is one way of solving this kind of inequality, in which we have like two inequalities. It means our expression is less than some expression but bigger than some other expression. So let's see how we can solve this by directly with the one approach. So let me just erase this part over here. Okay, so we have minus 3 less than equal to 2x minus 3 by 5. So minus 3 less than equal to 2x minus 3 divided by 5 less than equal to 3. So perform the, like we are trying to eliminate 5 from here. We are trying to isolate x over here. So for that we have to first eliminate 5. So we need to multiply either side of the inequality by 5. So when you multiply here, minus 3 into 5 less than equal to 2x minus 3 by 5 multiplied by 5 less than equal to 3 into 5. As we multiply by positive number, so this inequality sign will not change. This will eliminate 5. On the left side we left with negative 15 less than equal to 2x minus 3 less than equal to 5 3 is 15. Now to eliminate this 3, what we can do is we have to just add 3 on either side. So minus 15 plus 3 less than equal to 2x minus 3 plus 3 less than equal to 15 plus 3. So this plus 3 minus 3 cancelled. So here minus 15 plus 3 is minus 12 less than equal to 2x less than equal to 15 plus 3 is 18. Now we want x value. So here 2 is in multiplication. So we want to like eliminate that. So we need to divide either side by 2 by dividing 2 by dividing 2 by dividing 2. So there is no change in inequality sign because the 2 is positive. So this will cancel this and this will cancel this and give minus 6 x less than, and here it will give 9. So this way we can directly get the answer. Okay, now I hope it is clear how we can solve this kind of inequality. So let's see this example. 2x minus 6 less than equal to 4 and 7 minus 3x is greater than equal to 2x. So I'm leaving this as for you people to practice this and then comment down the answer in the comment box. Now Let's see, we have given an expression which is square root x minus 2, which is bigger than square root of 7 minus 2x. By seeing this example, what is the first point that is coming in your mind to solve this kind of inequality? So here, if you just recall the elementary properties of the inequality, like we have seen that if we have given any inequality and we are going to take the positive part, let's say we have a less than b, and if we are taking power of either side positive part, then there will not be any change in the inequality. So here, as this is a square root and this is also a square root, so if we are going to squaring both sides, if we are going to square both sides, so there won't be any change in the inequality symbol. But this square and square root will cancel each other, then we'll left with x minus 2, and here we're left with 7 minus of 2x. Now it resulted into a inequality that we have discussed before, right? So just go with the same approach and try to isolate the variable at one side, and then you can get the answer. Let's see, we have x minus 2 means we'll isolate x over here. So what extra things on the left will eliminate that. So minus 2 means we have to add 2. So 7 plus 2 minus 2x. So this got cancelled. X greater than 9 minus 2x. So here again we'll add 2x on either side. So that will give us x plus 2x. 9 minus 2x plus 2x. So this will cancel plus 2 and minus 2x. So here 3x greater than 9. Now we can isolate this x by dividing both sides by 3. So 3 by 3 cancelled, x value is greater than 3. If we are going to take x value greater than 3, then this will satisfy this particular inequality. It means x value greater than 3, x value greater than 3, it means x belongs to 3 to infinity. But here we need to be very careful, as we are getting the values of x to be bigger than 3, means any number which is bigger than 3, like 4, 5 or whatever number it will come, right? So but if you see here, come to this expression, if you are going to put x value to be 4, then this will become 8. 7 minus 8 will be a negative number, and a square root of negative number is not defined. Square root of negative number is not defined. So this is very important things while solving the questions on the inequality, that we should have to check the domain of each of the expressions in the inequality should satisfy the values that we are getting. So here, as per taking the square on both sides, we are getting the values of x to be greater than 3, means from 3 to infinity, but this is not the solution of this inequality. For the solution, we have to check the domain of each of the inequality. So domain means the values of the variable for which the particular expression to be defined. As a square root of any function, there's a square root of any functions, it will be defined, a square root will be defined if the value of fx is either 0 or greater than 0. If it is negative, means this square root will not be defined. So we have to look for the domain of this expression as well as domain of this expression also. So here, by taking a square on both sides, we got the values of x to be greater than 3. So keep this equation number 1. Now look for the domain of both expression x minus 2 as well as 7 minus 2x. So this x minus 2, square root x minus 2 is defined if this x minus 2 is greater than or equal to 0. So once you solve this, you'll get the values of x to be greater than or equal to 2. Means for this expression to be defined, the values of x should be greater than 2. Okay. And we are getting, by squaring both sides, we are getting the value of x to be greater than 3. So just this is mark it as second result. Now for this 7 minus 2x, this value to be defined, this should be 7 minus 2x should be greater than or equal to 0. Means then only this particular expression will be defined. Now try to solve this inequality, means try to isolate x on either side. So we'll do one thing, minus 2x, we added 2x on either side. So here 2x cancelled. Now this is 7 is greater than or equal to 2x. While solving this further, we'll get this 7 by 2 is greater than or equal to x. So this is third equation. By plotting this on number line, you can find the common region among all 1, 2 and 3. So see, from first equation, we are getting the values of x to be bigger than 3. From second equation, the values of x to be greater than or equal to 2. And from third equation, the values of x should be less than 7 by 2. So over here, let's say this is 2, this is 3, this is 4. So from first expression, as it says the values of x to be greater than 3, means values of x should be greater than 3. Now from second equation, the values of x should be greater than or equal to 2. Okay, so greater than equal means this should be shaded, greater than equal to 2. Now from third one, it should be less than equal to 7 by 2. 7 by 2 means nothing but 3.5. So here this is 3.5. Here this is equal to also, means the values of x should be less than or equal to this. So now among these all the three, we have to look for the common region. The common region in all, see, between this and this is this point, means from 3 to 7 by 2. And also if you think for the common in all, that is coming between 3 to 7 by 5. So the answer for this one will be value of x to be belonging from 3 to 7 by 2, close interval. Here 3 is open, right? But here 7 by 2 is closed, so we have to put the close interval over here. So this is your answer. So that's why it is very much important for the finding the common region. We are finding for the common region means we are looking for the intersections of all the possible values. So this is very important that whenever you are going to solve the inequalities, we must have to check the values of x should define each of the expressions, especially if you are dealing with the square root. You must have to be careful in this regards. So by squaring both sides, by using the elementary properties, we come up with this result. So we can't stop over here. We have to go for checking of the inequality should be defined. So what is the domain of this? For getting the domain of the square root, we have to take the expression inside the square root to be greater than or equal to 0. Like here I have taken for x minus 2 square root, we have taken x minus 2 be either greater than or equal to 0. From this, by solving this, we got x is greater than or equal to 2, and by this we have taken 7 minus 2x to be positive, and from here we got 7 by 2 is greater than x. By combining all these three results, we got the answers. Now let's check this particular inequality. Here you have to solve this inequality for a square root of x minus 3 minus a square root of 7 minus x is greater than 1, and the condition given is x is an integer, x belongs to integer. So here x is an integer, so we need to look for the values of x to be integers only. So here a square root, we have expression, this expression having a square root, this expression having a square root. So we need to look for the domain of each one. So for the domain of this expression, x minus 3 root is nothing but we have to look for x minus 3 should be greater than equal to 0. Once you solve this inequality, you will get the x value to be greater than 3. Now, if you are going to look for the values of domain for this expression 7 minus x, so you can find that 7 minus x should be greater than equal to 0, and you will get that x value is less than 7. So here, if you think of, okay, just look on the number line, the values of x is coming bigger than 3. Okay, and values of x is coming less than 3. This is actually x is less than equal to 7. So here we have 7 and 3. So we are getting the values of x greater than or equal to 3. From here we are getting values of x less than equal to 3. So between these the common region is 3 to 7. It means x values belonging from 3 to 7. So we need to look for, okay, whether this is the solutions of this inequality. If you are going to take any values between 3 to 7, let's say you are going to take 4. If you are putting 4, 4 minus 3 is 1, square root 1 minus of 7 minus of 4 is root 3. So here 1 minus root 3 is negative number, which this won't be bigger than 1. Here they are asking for the values of x to be integer. It means between 3 and 7 what all possible values of integers are. So the possible values of integers are either 4, 5 or 6, like 3, 4, 5, 6 and 7. So once we check this, we plug 3 over here, means this will be 0 and this will be some number, like 7 minus 3 is 2. So 0 minus 2 is negative number, right? If you just plug over here, 3 minus 3 is 0. So this expression is 0. And here negative 7 minus 3 is 4. So root 4 is 2. So 0 minus 2 is minus 2, which is not greater than 1. So this is not possible. Same you check for 4. So 4 minus 3 is 1. And here this is root 3. So 1 minus root 3. Root 3 is 1.732. So this is also negative. This is also negative. So this won't be bigger than 1. So this is also not possible. The same way if you are going for 5. So 5 minus 2, 3 is root 2. And this is also 7 minus 5 is root 2. So root 2 minus root 2 is 0. So 0 won't be greater than 1. So this is also not possible. So this way if we check for 6 also, 6 minus 3 is root 3 minus over here is 7 minus 6 is 1. So root 3 minus 1 means 1.73 minus 1. This is 0.73, which is not greater than 1, right? So this is also not possible. So the last possibility is we have to check for 7. If we are putting 7 over here, 7 minus 3 is 4, root 4 means 2. And here 7 minus 7 is 0. So 2 minus 0 is 2, which is coming greater than 1. So the possible values for the values of x that will satisfy this inequality is only the values of x is equal to 7. Now let's check this particular inequality. How we can tackle this kind of questions. So here we have given a square root of x minus 2 is greater than equal to minus 1. So we can solve this in a way that will be will do one thing, like many of the students will do the mistake in this, like this way they'll think of, okay, by squaring both sides we can make this free from square root. So see, we have given x minus 2 greater than equal to minus 1. If you are going for a squaring on both sides, that will give us s minus 2 square of this minus 1 square. So minus 1 square will be 1, and here x minus 2. If you are going to solve this, you will get x value is greater than equal to 3. But is this the solution? If we see this inequality, on left we have a square root x minus 2. So as we know, the square root is defined for any values either 0 or greater than 0. Okay, over here we have given x minus 2. If you think of for x is equal to 2, then this will become 2 minus 2 is 0, means root 0. Root 0 is 0, which is obviously greater than minus 1. So here we are finding value of x to be 2, which is making this statement true. So if you think of any number bigger than 2, let's say 2.5, then 2.5 minus 2 is also positive, and if square root of positive number is positive. So that value will be obviously greater than minus 1. Same way, if you think of any value just bigger than 3, just smaller than 3 and bigger than 2, then all will give us this x minus 2 to be positive and the square root of positive number to be positive. So that will give us number greater than minus 1. So in this way, we can find that there will be a value from 2 to 3 which will also satisfy this inequality. But with this method, we are not getting the values between 2 and 3, means there is a loss of root. To avoid this loss of roots, what we'll do is we'll look for only things over here like x minus 2 to be either 0 or greater than 0. It means if any values of x we are taking greater than 0, then this will be any value we are taking greater than 2 or equal to 2 over here, then a square root will be defined and a square root value will be positive. So that will be greater than minus 1. So in this case, we can find the root for this to be nothing but all values of x which is either 2 or greater than minus 2. So all values of x lying from 2 to infinity. So for solving such kind of inequality, we have to just look for the domain of the expression. As here in this case, this is a square root of x minus 2. So a square root will be defined if the number inside the root should be positive. So here you can find that x minus 2 to be positive. Then if you are going to solve it, minus 2 goes other side and you'll get it as x greater than 2. So which will implies that the root of this inequality is all values of x from 2 to infinity. Okay. So let's move to the next part. This is also one of the important result in inequality. Squaring of inequality. Like we have seen the elementary properties, like if a less than b and we are taking the positive parts of the inequality, then the inequality sign doesn't change. But here a squaring of the inequality means we are looking for the specific value of the exponent which is equal to 2. So let's say we have given an inequality. Let's say if we have a less than b, then a square less than b square. This will not always true. This will not always true. So let's see. This will not always true because see with example we'll understand this. Suppose we have minus 4 less than 2. But if you are going to take the square of minus 4 and a square of 2, then a square of minus 4 is 16 and a square of 2 is 4. Here a square of minus 4 is coming bigger than a square of 2. So here by taking a square on the either side of the inequality, it changes the inequality sign. But if we are taking one example like this, we are taking 2 less than 5 and taking a square on both sides, then we are getting 4 less than 25. So here the inequality change is not, sign is not altered. So this a less than b, then a square minus b square will be true only if both a and b are of positive sign. So here you can see. So first thing is, okay, we'll see this for different example to come up with the result. If a less than b, then a square less than b square if both a and b are positive. So we can see this as if a less than b and here this is positive, then this will be true. Or if we are looking for, okay, now suppose we have minus 2 also less than 3. Here this is negative, this is positive. If we are going to take the square of this two number, then here this is 4, this is 9. So here this is having same inequality symbol. So this is obvious. If this is the case, then this will always be true. But here we have taken this number minus 4 less than 2 and minus 2 less than 3. Here in this case we found that the square, by taking a square, the inequality sign is changed, and here the inequality sign doesn't change. So to come up with the result, we have to keep it in mind if the two numbers in an equality of alternate sign, means if a number is negative, another number is positive. If a number is negative and other number is positive, then the inequality sign will not change. If, see here, if a is less than b and here this a is negative, b is positive, and we are taking a square of a and taking a square of b, then this inequality sign will not change only if the distance of this point minus a from the origin is less than the distance of the point b from the origin. So if we talk about distance, means we'll not see the negative sign over here, we'll see the value of this. If here this is minus, let's say this is minus 4 and this is, let's say, 5. So now the distance of this point minus 4 from this origin 0 is less than the distance from this point P. Then in that case, if you are going to take the inequality square both sides, then inequality sign will not change. But if the distance of this negative number from origin is more than the positive number, let's say this is minus 5 and this is 4. So here distance of this point from origin is 5 unit and this is 4 unit. So if you are going to take the squaring on both sides, then the inequality sign will change. So basically, if in inequality, if you are looking for one of the number is negative, then you have to look for the numerical figure. If the numerical figure over here is bigger, then in a square of that, the inequality sign will change. So you can see this example. Let's say we have minus 8 less than 3. If you are going to take the square on both sides as this numerical figure is bigger than this, so in square values means negative 8 square values will be bigger than square of 3. So here by taking the square, the inequality sign will change. Now same example, if I'm taking, let's say, negative 2 and here 5. So now you can see that the numerical value over here is smaller than this. So if you are going to take a square on both sides, then there is no change in the inequality sign. Now let's find the values of x square when x greater than 2, x less than equal to 2, x less than minus 2, and last x greater than minus 2. Let's take the first part, x greater than 2. Now here, if x greater than 2, we need to evaluate the x square as 2 is positive. So values of x greater than 2 means it will also be positive. And we know that if in inequality both numbers are positive, so by taking the square on either side, there will not be any change in the inequality sign. By using that, we can directly square on either side. X square greater than 2 square means x square greater than 4. It means value of x square belonging from 4 to open interval 4 to infinity. Here open interval because this is only greater than, not equal to. So we just have to keep the open interval over here. Now let's take the second part. We have given x less than or equal to 2. So value of x less than equal to 2, it means less than 2 means either it will be positive or it might be negative. So let's break this into the positive values of x as well as negative value of x. So here we can find that x value either less than equal to 2 and greater than 0, or x value is greater than equal to 0 but less than, less than equal to 0 and greater than minus infinity. So these are the two possibilities we have. Now in order to find the square of the number, here we can find either side of this number is positive. So if we are going to take the square, then there won't be any change in the inequality sign. So here we'll get x square less than equal to 2 square, and 0 square is also 0. So this is what we got from here. As well as if you are going to take the square over here, now as negative number is in infinity, very big number, if you are going to take the square of any number, either negative or positive, always will get the negative. So here negative infinity is very big number, so its square will be a very big number, positive number. So that will come as a infinity, and 0 square is 0. So we can get over here x square to be less than infinity but greater than equal to 0. Here this inequality, in this inequality sign, equal to will not come because this is infinity. So always at the infinity point there should be only less than or greater than inequality. Okay, so from here we got x square value is less than equal to 4, or here we are getting the value of x square is greater than 0 and less than infinity. As here this is or means union, it means this is nothing but belonging from less than 4 means and greater than 0 means the values of x square is from 0 to 4 union, here 0 to infinity, 0 to infinity. So here if we are taking the union of these two, that will give us x square belongs to 0 to infinity. So we can check because 0 to 4 means here this is 0, this is 4, and this 0 to infinity, this is 0 to 4, and 0 to infinity means from here to all this direction, all this right of this x-axis means up to very infinite distance. So the union of this value and this bigger value will be the bigger value. So this will be x square belonging from 0 to infinity. Now let's come to check the third part of this. X is less than minus 2. If x less than minus 2, it means the value of x is smaller than minus 2. So less than minus 2 means it will be negative. X value will be negative. Both are negative. So whatever be the value of x, you are going to take a smaller than 3, that will be a smaller than 2, that will be like, see, if you just see on the number line, this is 0, this is minus 2, and x value over here is given as smaller than 2. So it means if you're going to take the square of this value, it will come always bigger than the square of 2, because the distance of minus 2 is this much, and whatever be the value we are going to take over here, that distance from the 0 will be bigger. So if you're going to take the square of x over here, then it will be like x square, as both the numbers are negative, so it means it will give us the square of negative 2, and the sign will reverse, so x square value will be greater than 4. If we think in another way, like, okay, it means that x square value is greater than 4, means this will become nothing but x square belonging from 4 to infinity, both open interval, because here open interval we have. So now let's check the last part of this question. We have given x value is greater than minus 2. So greater than minus 2 will be either minus 1, minus 1.5, something like up to 0, all number will be negative. And if we are going bigger than that, that will be positive. So here the values of x is break down into two part, that is either x is greater than minus 2 but less than or equal to 0, or x value is less than 0 but greater than infinity. Now if you are going to take the square over here, now as the distance of this point, either side of the x having the opposites, and this 0 is like neutral, but here this is negative, it means this point is much farther than this point, or this is originally, right? So if you are going to take a square of this, then this will give us what? 0 square is 0 and minus 2 square is 4. Over here the same thing will come, like 0 square is 0 and infinity square will be infinity. So x square lies between 0 to infinity. So by taking union of both these, like this is 0 to 4 and this is 0 to infinity, here 0 is included, so x square value will belong from 0 to infinity. Now let's see one of the important properties of inequality, the reciprocal inequality. So if we have given an inequality either less than or greater than type, and if we are taking the reciprocal of either side of the numbers, then by doing that, whether the inequality sign is changing or not, that we have to check in this. So here let's say we have given an inequality a less than b. If we are going to take the reciprocal of a and the reciprocal of b, then whether the inequality sign change or not change, that we need to look into this. So if we are changing the inequality sign, if we are changing the reciprocal of the number, then the inequality sign change if either of the number, left or right, both having same sign, either both positive or both negative. In that case the inequality sign will change. So let's see one of the example to understand it in a better way. Suppose we have given 2 less than 3. If we are going to find the reciprocal of 2, then it will be 1 by 2, and reciprocal of 3 is 1 by 3. 1 by 2 is 0.5 and this 1 by 3 is 0.3 bar. Now here 0.5 is bigger than 0.333. So here we found that both the number 2 and 3 are positive, and by taking their reciprocal we are getting the values to be like 1 by 2 is bigger than the values of 1 by 3. So here by doing the reciprocal we got the inequality sign to be reverted. Let's check for one more example. Suppose we have 5 less than 6. If we're going to take the reciprocal of 5, that will give us 1 upon 5, and reciprocal of 6 is 1 upon 6. Now 1 upon 5 is 0.2 and 1 upon 6 is 0.16 bar. Again this number 0.2 is bigger than 1/6 bar. So here you can find it like by taking the reciprocal of these two positive number on B. We got that the values has changed, means the reciprocal value is bigger than the earlier numbers. So here the inequality sign changed from a smaller than to bigger than sign. Now let's take one more example. Let's say we have -3 less than -2, both number having same sign, but this time I have taken negative number. If we are going to take the reciprocal of -1 -3, that will be -1 upon 3, and reciprocal of -2 is 1 upon 2. Same here, like 1 by 3 is 0.3 bar, and this is -0.5. So here also this -0.3 bar is bigger than -0.5 bar. So again we have seen that okay, by like taking the reciprocal of either side of the number, the inequality sign is reverting. Now what if the either side of the numbers are having opposite sign? So let's see, if A and B both having opposite sign, it means B is bigger, means obviously opposite sign means B should be positive, then A must be negative. I mean here A negative and B positive. So we can write this in another way also, like A negative and B positive. So if we are going to take the reciprocal of this number, then whether the sign will interchange or it will be the same. So let me just check. Okay, if you are going to take the reciprocal of this number, it means that will give us nothing but 1 upon A, and this is 1 upon B. So here in this case we can foresee, because whatever be the value we are going to take, reciprocal of 1 by A will be negative only, because A is smaller than 0 means it is negative. So 1 upon A is also negative. As B is positive, so 1 upon B is also positive. So the sign of inequality won't change. For example, let's say we have given -2 less than 5. If we are going to take the reciprocal of -2, this will be -1 upon 2, and reciprocal of 5 is 1 upon 5. Here reciprocal of -1 2 is 1 by 2, -1 by 2, which is nothing but -0.5, and this is 0.2. See here, this number is negative, so obviously this will be smaller than the positive number. So here by taking the reciprocal of the numbers in which the inequality in which one of the number is negative, one of the number is positive, then there won't be any change in the inequality sign. So this is one of the very important result in inequality. So let's try to solve some question based on this, like how we can use this inequality for finding the range of some rational expressions or range of some quadratic values. So let me just take one example based on this. But before going to solve the problem on finding the range of rational expression, let's try to practice some question based on finding the reciprocal values of an inequality. Suppose we have given, or let's say we have given x greater than 3, then we need to find 1 upon x. So here we have given the value of x greater than 3. It means the values of x is greater than 3, and it might be any bigger number, let's say infinity, right? Bigger, greater than 3 means what? 3 is there, okay, and all number bigger than that means all numbers means that is 3 and bigger than that is nothing but up to infinity. So we have x values either greater than 3 or less than infinity. As this number is positive and this infinity is also positive, if we are going to take the reciprocal, then there won't be any change in the if we are going to take the reciprocal as both having the same sign, so the reciprocal sign will change. So just take the reciprocal of 3, it will be 1 upon 3 and the sign will change to 1 upon x, and this will also change from less than to greater than, and this will be 1 upon infinity. As here in denominator 1 we have, right? So by taking the reciprocal, that will be 1 upon infinity. As infinity is a very large number and you are going to divide 1 from a very large number, it means it will be very close to 0, so we can write it as 0. As here less than as here greater than 0 value means it will not come exactly 0. So here we got 1 by x to be greater than 0 but less than 1 by 3. So 1 by x value is belonging from 0 to 1 by 3. Here 0 and 1 by 3 both will be not included because here this symbol is of only greater than, and this in this case never this point will be included because here infinity is there, so it will be always open. Okay, now let's see if we have given let's say value of x to be less than any negative number, let's say negative 3. So it means what? The value of x is minus 3 or any number less than 3 means x is greater than minus infinity and less than minus 3. As either side of x values are negative means by taking the reciprocal of these number, the inequality sign will change. Negative infinity by 1 means this will be 1 upon negative infinity, and this will change to greater than, and this will be 1 upon x, and this is 1 greater than minus 1 by 3. So here again 1 upon very big number means very big number in negative sign, just ignore the sign. 1 upon negative 1 upon infinity means again it will tend to 0. So this is 0 is greater than 1 upon x is greater than 1 upon 3. It means x value is nothing but belonging from minus 1 by 3 to 0. Here also open interval because this is minus 3 is only like greater than x but not equal to x. Now let's take one more example. Suppose we have x value which is like from minus 2 to let's say 2 except 0. So minus 2 to 0 will also come, but we are subtracting this 0 means offset containing 0 means 0 is not included in this. Then we need to find the value of 1 upon x. So here this is very important to understand that here x is belonging from minus 2 to 2 and 0 is not included. So we can break down this as x belonging from minus 2 to 0, 0 not included, and also from 0 to 2. Here except 0, 0 is not included here also, 0 is not included over here, except 0, minus 2 to 2, all the values are included over here. Now if we are trying to break it down means x belonging from minus 2 to 0 or 0 to 2, so we can write it as x value is less than 0 and greater than minus 2, or here we can write it as x value is less than 2 and greater than 0. Now if we are going to take reciprocal on either side, we'll get it as negative 2 reciprocal is negative 1 by 2, and the inequality sign will change from less than to greater than, and this will be 1 upon x, and this will be 1 upon 0. Here inequality sign is changing because x value is less than 0 means this is negative, here also negative, right? Same side on other side. So that's why we need to change the inequality sign. One more thing over here means the value of x is not equal to 0 but it is very near to 0 means value of x is negative. So here this 0 in the denominator means we are dividing 1 by 0. So this 0 is actually very near to 0 which is approaching from negative side of 0 means this number is negative. So if you are going to divide 1 by negative 0 it will give us a very small number, that is negative infinity. So this will become 1 upon 2 greater than equal to greater than 1 upon x, and this will be negative infinity because if you look over here this is 0 and the value of x is less than 0 means it is not exactly 0 but approaching towards 0 means whatever be the point over here we are going to take, that will be negative. So we are going to divide 1 by a very small, very bigger negative number. So it means just see 1 is dividing by very small number, it means that will give a very bigger number over here. But as this is negative, very bigger number means infinity, as this is negative, so it will come negative over here. The same thing we need to just apply over here. This is x value is bigger than 0. It means this is not exactly 0 but approaching towards 0 from the positive, so it will be 1 upon 0. Now this is positive number if we are which is very small, and dividing it by 1 by very small number means it will give a very big number. Now here also both side numbers are same sign, so inequality will change to less than to greater than type. So here this is nothing but greater than 1 upon x greater than 1 upon 2, so this will give us infinity 1 upon x greater than 1 upon 2. Now here if you can find it, the values of x from minus infinity to minus 1 by 2, and here from 1 by 2 to infinity. So here or means union, but just look take the union between this. So x 1 upon x belonging from minus infinity to minus 1 by 2 union 1 by 2 to infinity means except between minus 1 by 2 to 1 by 2 all the values of real number will come as a value of 1 upon x. Okay, now we are going to discuss one of the important topic in inequalities, the method of solving inequality, which is Wavy curve method. So what exactly Wavy curve method is? It is used for solving the inequality involving polynomials or rational expression. So suppose let's say we have given a polynomial fx and it is greater than 0. So this is an inequality in which if we are looking to find the roots or zeros of this inequality, we have to first look into the like factors of this polynomial fx. Suppose let's say we have a factors of this polynomial fx is x minus a, x minus b, and x minus c. So this is greater than 0. Now if we want to find the zeros for this, what we'll do first is we'll try to find the critical point for these expressions. So the critical point of an expression is nothing but values of the variable which make this expression become 0. Now if you can find over here like this, x minus a into x minus b into x minus c will become 0 if you are putting either x minus a 0 or x minus b equals 0 or x minus c equals 0. So from this you can get, okay, x is equal to a, x is equal to b, and x is equal to c. These are the three different values of x that can make this expression to be 0. So these are the critical point. So first we need to find the critical point of the given expression, and then we need to like put those point on a number line in an ascending order. Suppose among these A, B and C, the bigger one is, let's say, C. So we'll put C over here, and then like B is bigger than A and A is the smaller among all. So we'll plot this all point on a number line, and then in order to like draw the curve for this expression, we have to first see the sign of this expression, like whether it is minus of fx or it is plus fx. So as here in this case, this expressions on the left is positive. So if it is positive, then we have to start making curve above the line from the extreme point, like very right point. Okay, so this is the right point. So from here, we'll take a curve which will come up to this point A. Now, one more thing is there. We have to be very careful in like making a taking either this point will be included or not. So for that we have to check the inequality. If it is only greater type or less type but not equal, then this point will not be included and will make a hollow circle at this point. Now as we reach at this point C, now we need to just look the factor from for which this is the critical point. Here this is the factor. Now we have to decide whether the curve will go down or it will continue above the line to the point B, which will be decided by the exponent of this linear factor x minus c. If the exponent of this linear factor is an odd number, then this curve will change its like direction from above the line to below the line. As in this case, x minus 1 power is 1, which is an odd number, so it will change the direction from above the line to below the line, and it will reach to the point B. Here also, as this is only greater than, so at every point there will be a hollow circle. So here also hollow circle. Now we reached at the point P. We have to again check the linear factor for which this B is the zeros. So here x minus B is the linear factor, and the power of this is an odd number. So again it will change the direction from below the lines to above the line. So above the line will mark it as positive, below the line will mark it as negative. So again this is positive. Now we reached at point A. Again we look into the linear factor x minus a, which is having power 1. So again it will reverse the sign from positive to negative. Now this way, this white curve that we have drawn is known as the Wavy curve. This is the only this is just for knowing what is the region on this number line which will be positive or negative. Accordingly, we have to look for the given inequality. As the given inequality is positive, it means we have to look for the region where the Wavy curve is giving you positive sign. So here you can find positive sign over here between A and B and bigger than C. So we can write it as okay. So this solution of this is nothing but x belonging from A to B, both open interval, because here this is a hollow circle, and here as well as this as well as we have bigger than C, means from C to infinity. So this R is nothing but union. So the solution for the inequality is given by AB union C to infinity. Now what if we have equal to in place of this greater than, we have greater than equal to symbol? Then in that case we'll include all these points, like we'll shade all this point, and that point will be included in the interval. So let's see. Here we have a linear factor given as x minus a power 2, x minus b, x minus c, and this is greater than equal to 0. So first thing is we have to make this expression to be positive. One important thing is that we need to notice over here is we can use this Wavy curve method, means only if the coefficient of each variables, coefficient of x in each factor should be positive. This is the very important point that we need to keep it in mind. Coefficient of x should be positive. Okay, we'll see the different questions and then we'll understand why it is needed. Okay, so from here, if we can find the critical point for this, means by equating each factor we'll get x is equal to a, x is equal to b, x is equal to c are the critical point for this expression. Now draw a line, plot this point on this in ascending order. Okay, this, let's say I'm taking c as b as the bigger among all, so we'll write and a is the smallest, so a, c and b. Now as this inequality is of greater or equal to, it means all this point will be included in the solution. So for greater than equal to, if the solution is included, we will always use the shaded circle at each of the critical point. Now as the sign over here is positive, so VAB will start from above the line and it will reach to B. Now here B is the zero of this particular factor and the exponent of this is an odd number, so the curve will change from positive to negative and it will reach to C. Now here also C is having this factor having the power an odd number, so again it will change from negative to positive. Now a is the zero of this linear factor x minus a. Here the power is even, so if the power is even, then the curve will not change its direction from positive to negative. It will continue in the same directions as positive. So now here we got the like Wavy curve over here. Now look into the initial inequality, which is greater than equal to 0. Greater than equal to 0 means positive. So look into this Wavy curve, which all region having the positive sign. So those region will come in as a solution. So here you can find that less than A and less than C, okay, both are positive. So directly you can say that the values of x from minus infinity to C. So here x belonging from minus infinity to C as well as from B to infinity. Now here you can find that this is shaded, means this point will be included, so we must have to keep the closed interval at the end of C. Always make sure at the end of minus infinity and plus infinity there should be open interval. Now here from B to infinity, so union closed interval B to infinity. Now let's check this example. Here we have given this expression which is greater than 0. So first thing you have to look for the coefficient of each variable should be positive, as here coefficient is 1, here 1, but here negative. So we must have to make this coefficient to be positive. So as 1 minus x, if we want this x coefficient to be positive, so by taking minus common it will become x minus 1, right? So we can write this whole, then this whole expression will become x minus 3, x minus 2 and minus of x minus 1, means this whole expression will be negative. Now here the first primary thing that we needed is to make the coefficient of each variable positive, that we have done. Now here you can see that this expression having negative sign. So we can solve in this way also, but it is recommended to make this whole expression positive. For that, what we need to do is multiply both sides of the inequality by negative 1. So by multiplying inequality by negative number, it will revert the sign. So if you multiply this expression by negative 1, then this will become x minus 3 and x minus 2, x minus 1, and this expression inequality will change its direction, and 0 into minus 1 is 0. Now we got the standard form. So just finding the critical point from here. So if you equate this one and this one equal to 0, you will get from this x is equal to 3, x is equal to 2 and x is equal to 1. So plot this point on number line. So which one is bigger? 3 is bigger, so that will be on the extreme right. So here 1 2 and 3. Now as we made this expression as a positive, so we just have to take the curve from above the line. So now here we started curve from above the line and we reached at the point 3. Here whether 3 will be included or not will be decided by the inequality, as this is only less than not equal to type. So here we have to just make a hollow circle. This will indicate that this point will be not included. Now 3 is the zeroth of this factor x minus 3. Here the power of this factor is 1. You can find if each factor is having power 1, means at each critical point you have to just revert the sign of the verb of the curve. So here coming from positive, it will goes to point C. Again 2 is point 2. This point 2 is not included. All this point will not be included. So we just have to make a hollow circle at each critical point and just reverse the sign from here to here, because the exponent of this factor x minus 2 is also odd, and here x minus 1 factor exponent is also odd, so here also it will change the sign. So here we got this region positive, this is a negative, this is a negative. Now we are looking, we have drawn the Wavy curve from this expression, so we just have to look the sign over here. This is less than 0 means negative. So we need to look for the negative region, which is here. Less than 1 means minus infinity to 1, and greater than 2 but less than 3. So here you can write it as x belonging from minus infinity to 1. Both open interval, because this point is not included, and union open interval 2 to 3. So this is the solution for particular inequality. Now one thing over here, a question might come in your mind, why it is needed to convert this, why not we can directly solve this from here. So if the sign over here of this expression is negative, so in that case we can also do the same thing, like find the critical point. But in this case what we can do, instead of taking the curve from above the line, as this sign is negative, so we have to take the curve from below the line and then continue the process. It will come like this and this and this. So this is negative, and this is positive, this is positive. Here in this case this is positive region, so we need to look for positive region, which is minus infinity to 1 and 2 to 3. In both cases you will get the same answer. So but it is recommended to to avoid any kind of confusion, just if it is whole expression coming negative, multiply both side by minus 1 and reverse the sign like we have done over here. Now let's see one more example we have. Given 4 divided by x is greater than equal to 5. Okay, so if you are going to think, okay, we can solve this by using cross multiplication, then or like multiplying both side by x to cancel this x from the denominator, then you are wrong, because here we don't know whether x is positive or x is negative. So if such kind of question is there given, then we need not to go in this way. We just have to bring whatever be expression on other side of the inequality, we must have to bring on one side of the inequality and make any one side to be 0. So here, as in this case, we have given 4 by x greater than equal to 5, so we can write it as 4 by x. So to eliminate 5 from here, subtract 5 from both sides. So on the right we left with 0. Here 4 divided by x minus 5. Now just simplify this. X 4 minus 5x is greater than equal to 0. Now we got over here expression of P upon Q form. P upon Q form. P upon Q form. So any expression of this format, P upon Q form, where Px is also polynomial, Qx is also polynomial, but this denominator Qx should not be 0, then this type of expression we call as rational expression. Rational expression. Now we'll proceed in the same way. In order to find the zeros of this inequality, we have to find the critical point of numerator as well as critical point of denominators. So critical point of numerator you can obtain by equating 4 minus 5x is equal to 0. That will give you x is equal to 4 upon 5. And denominator you can get it by equating it equal to 0. So the critical points are 4 by 5 and 0. So draw a line, plot this point, critical point 0 and 4 by 5 on it. Now we have to check the inequality. It is of greater than equal to. So we have to go and shade the critical point which should be included. So here I'm going to shade it as like dark circle, but here I'm going to make this a open circle. See, one thing keep it in mind, if in a inequality of this rational expression form, whatever be the critical point coming for the denominator, that should not be included. That should not be included. If you are going to put 0, means you are including this 0 in the solution set, means 4 minus 5x upon 0. Any number divided by 0 will be undefined. So for whatever be the expression coming in the denominator, you have to find the critical point for that, but you should not include in the solution. Means you have to you have to make a open circle for all those critical point lies in the denominator. Now, after this, you just have to start making curve. So as this expression sign is positive over here, so the curve will start from above the line. Okay, now this is positive. Now this expression, one more thing here we need to keep in mind, like whether we can go in this way. No, we can't proceed until unless we are going to make the coefficient of x to be positive. Here you can find that the coefficient of x is negative, so we can't use this until unless we are making this positive. So try to make this positive. So to make this positive, what you can do is multiply both sides by -1, so that will give us 5x minus 4 by x. By multiplying both sides by -1, so inequality sign will be reverted. Now here we have this one, so 5x minus 4. Now we got the curve to be okay after plotting this to critical point. So this expression is positive, so curve started from above the line. Now as the power of this linear factor is 1, so it will change its direction from positive to negative, and it will reach to 0. Again 0 means this solution of x is equal to 0 is nothing but the 0 of this linear factor x minus 0 to power 1. Here also power is odd, so again it will change its sign from negative to positive. Now we have drawn the curve from this, and this expression is less than equal to 0. It means we have to look for the region where it is negative, where the curve is negative. So here we can find that the curve is negative between 0 to 4 by 5. The solution set is x belonging from 0. 0 is at 0 we have open interval, and 4 to 5 at this point we have closed interval, because here we have dark circle. So here we have given rational expression on left and right side 4, so we'll make the right side to be 0. So for that, subtracting 4 both sides will give us 6x square minus 5x minus 3 divided by x square minus 2x plus 6 minus 4 less than equal to 0. Here we have subtracted minus 4 both sides, so by subtracting same quantity on either side does not impact the inequality symbol. So now by simplifying the left hand side, we'll get x square minus 2x plus 6, and this is 6x square minus 5x minus 3 minus 4x square, this multiplied by this whole expression, so minus plus 8x minus 24 less than equal to 0. Now once we simplify, 6x square minus 4 means 2x square minus 5 plus 8 is plus 3x, and this will become minus 27 divided by x square minus 2x plus 6, which is less than equal to 0. Now factorize both numerator and denominator. So here we have middle term 3x, so by splitting the middle term we have to check the multiplication of this 27 and 2 should be equal to like if you are going to split this number into two parts, the product of those two should be the product of coefficient of x square and constant. So here we can get it like product of 27 and 2 is 54. So we need to just split this number in such a way that their sum should be plus 3 and product should be minus 54. So we can take it as 9 and 6, 9, 6. So this will become 2x square plus 9x minus 6x minus 27. And on the denominator we have x square minus 2x, so we can make it a perfect square by using the identity. We can write this 6 as 1 plus 5, so this will become x square minus 2x plus 1 plus 5, which is less than equal to 0. Now numerator, by doing the rearrangement, we can write it as 2x square minus 6x plus 9x minus 27 divided by, here this expression will be x minus 1 whole square plus 5 less than equal to 0. Now once we take the common factor in numerator, here we can get it as 2x x minus 3 plus 9x minus 3 divided by x minus 1 whole square plus 1 plus 5 less than equal to 0. So the numerator will be x minus 3 into 2x plus 9 divided by x plus x minus 1 whole square, x minus 1 whole square plus 5 less than equal to 0. Now here in the numerator we got the linear factors which is having positive coefficient of x, here also positive coefficient of x, and in the denominator we have x minus 1 whole square plus 5. Now we are looking for the critical point for the numerator as well as denominator. If you think of this denominator is x minus 1 whole square plus 5, so a square of any number will be always positive. So this x minus 1 is positive, and in positive number we are adding some positive number, means this won't be 0 for any value of x, because already this x minus 1 square is positive, so we can get 0 only we are adding the negative number, but here we are adding the big positive number, right? So the denominator will not give us any critical point, so we just have to equate the numerator equal to 0 to get the critical point. So from numerator we'll get x minus 3 is 0, means x is equal to 3, and from this we can get it as minus 9 by 2 as the critical point. So critical point are 3 and minus 9 by 2. Now we just have to plot this point on a line, and once we plot this on a line, then we'll see that the critical point are 3 and minus 9 by 2. So here minus 9 by 2 and 3. Now as the inequality sign including less than or equal to sign, and the critical point came from the numerator, so all these points will be included, so we have to share it. Now start taking the curve, as this expression is having positive sign, so we'll take the curve from up and positive, and 3 is the linear factor over here, exponent is 1, so it will change the curve from positive to negative, and again from here also linear factor power is 1, so it will change from negative to positive. As the whole expression is negative, so we need to look for the region where the curve is negative. So curve is negative between minus 9 by 2 to 3. So the answer or solution for this is x belonging from minus 9 by 2 to 3. Both minus 9 by 2 as well as 3 will be included. Now let's move to another question. Over here we need to find the all possible values of this polynomial, or you can say function f(x) given as 1 minus x square upon x square plus 3. So it means we need to just find the values of this function. So if such kind of question is there, or might be they will ask you like in place of all possible values, they might ask find the range of the function. So in such a type of question, what we'll do is we'll equate this expression to any variable, let's say y, and as the expression in x is quadratic over here, also this is quadratic, so we'll try to simplify this expression, and we'll get some kind of non-equations. Let me just cross it this way. So we have 1 minus x square divided by x square plus 3 equal to y. So once we do cross multiplication, as this is equation, right? So we need not to worry about doing cross multiplication. That things we are thinking for the inequality, because by multiplying by negative or positive sign, the inequality sign matters. But in equation there is nothing such like this. So by doing that, we'll get 1 minus x square is equal to y times of x square plus 3. So further simplifying this, we'll get 1 minus x square is equal to y times of x square plus 3 times of y. Now try to bring all the terms on one side. So we'll get it as, on the left side we have 0, all number I shifted to the right side, then this will become y x square minus plus x square plus 3y minus 1. So over here, this, if you see x square by taking common, we'll get it as y plus 1 times of x square plus 3y times of 1 equal to 0. So now this is, if you see, this is quadratic in x or not. So this equation is quadratic in x. So y plus 1 x square plus 3y minus 1 equal to 0. So here this is x square. So as this is quadratic in x square, so here we just want the values of this expression fx. So here this is having term y and this is also having term y, only one variable is containing x. So we'll try to get the values of x square from this equation. So by shifting this expression on the right side, that will give us 1 minus of 3y, and this also goes to denominator. So this is 1 minus 3y upon 1 plus y. Now here x square value we got as 1 minus 3y divided by 1 plus y. Here, if whatever be the value of x we are going to take, x square value is going to be positive. Either if you are taking 1 or 2 or 3 as a positive value, it will be positive, or if you are going to take minus 1, it will be again positive. If you are going to take minus 2, also positive, and if you are going to take 0, then this will be 0. It means the value of x square is always either greater than 0 or equal to 0. So by doing this, okay, we are getting the inequality in y. So here we got this inequality 1 minus 3y upon 1 plus y greater than or equal to 0. So we need to just solve this inequality. So 1 minus 3y upon 1 plus y greater than or equal to 0. Now here in the numerator we have linear factor in y, but the coefficient of y is negative. So we want to make it positive. So we'll multiply both sides by minus 1 and invert the inequality symbol. So then this will become 3y minus 1 divided by 1 plus y less than or equal to 0. Now we got the rational expression. In numerator we have 3y minus 1 and denominator 1 plus y, and which is equal to or less than 0. So we need to find the critical point of both numerator and denominator. By equating this 0, we'll get 3y minus 1, 0 means y is equal to 1 by 3 and y is equal to minus 1. These are the two critical points for this inequality. Now we have to just draw the line and plot this point on the line, minus 1 and 1 upon 3. As this inequality is of less than or equal to, so we need to put the dark circle at the point where the critical point is of numerator. So only at 1 upon 3 we have to put the dark circle, means we have to include this. And for denominator critical point, we should have to take a hollow circle, means this point will not be included in the solution. If it is included, means this whole expression will be undefined. That's why we have to take it a hollow circle, means we need not to include it in the solution. Now start taking, as this whole expression is positive, the curve is positive and the power is odd, so it will change from positive to negative and again from negative to positive. So here this is positive, this is negative. Whole expression is less than or equal to 0 means negative, so negative reason is from minus 1 to 1 by 3. So the solution for this is y belonging from minus 1 to 1 by 3. Here 1 by 3 is included in the solution set. Now one thing we need to keep it in mind, this is the value of y which we assume for fx, means this is the all possible value for fx. So fx possible value is nothing but minus 1 to 1 upon 3. Or you can say that this is the range of the function fx. One more type of question they might ask, like here all possible values of fx or range, or they might ask the maximum value of the rational expression, this expression, or minimum value. So in all such cases we have to just proceed in the same way. We need to look for the values of this y. So we'll get a range of values. From that you can find that okay, this is the smallest value is nothing but -1, which is not included, right? It means any number which is bigger than -1. So we can't say which is the minimum value over here, but it is assured that the maximum value is 1 by 3. So this is maximum value of this expression is 1 by 3, but minimum value is very near to -1. Now let's see, we are going to derive some of the important result on inequality. So here we have given x square less than a square. So just think of, okay, this is inequality. So if you are making one of the side to be 0, means subtracting a square either side, will get it as x square less than 0. Once you write it as x square minus a square, means by using the identity x minus a x plus a, we can write. Now this is into the form of product of a linear factor, so we can use the Wavy curve by equating the critical point over here. So critical point will be from this 0 from this a, and by equating this to 0 minus a, so the critical point are a and minus a. So by plotting this on x axis, the critical point are minus a and a. So by drawing the Wavy curve over here, positive, as all the coefficient of x is positive. Now all the factors having odd power, so the curve will change from positive to negative, and then negative to positive. As this inequality is less than, so this point will not be included. So from here the negative region is minus a to a, and here the inequality sign is minus a. So if we have given like this, so we can get the solution to be from minus a to a. So this is the direct result that we need to keep it in mind, that we can directly use in a problem solving. So whenever we have given expression x square less than a square, then we can write it as x less than a or greater than minus a. And this is vice versa, means if we have given this also x lying between minus a to a, then x square is also less than a square. But if in place of this less than, if we have less than equal to symbol, then the same thing will be there, but we have to just put equality symbol over here. So just see this, suppose we have x square less than equal to a square, then in this case what we'll get is this point a will also be included, as well as minus a also included. The same way you have to solve this, x square minus a square less than equal to 0. This will be x minus a, and x plus a less than equal to 0. Critical point will be x is equal to a and minus a, plotting on number line minus a, and the curve will be positive, negative, and then positive over here. So positive, negative, positive, as this inequality is of less than equal to, so this point and this point both will be included. So the solution set will be x belonging from minus a to a. So this is the direct result that we have to remember. If x square is less than a square, then x lies between minus a to a, and both minus a and a will be included. Now if we have x square is greater than a square, x square greater than a square, so just go for the same method. Subtract a square either side, we'll get this one, factorize it, x minus a, x plus a greater than 0. The critical point will be a and minus a. By plotting it on x axis, minus a, and draw the curve as all the linear factor x coefficient is positive, so this will come positive, and all having odd power, so this is positive, and then this will be reverted the sign from positive to negative, and then negative to positive. as the inequality is not involving equal to symbol, so this 2 point will not be included. So as this expression is positive, we need to look for the positive region. So positive region is this, less than minus a. It means from minus infinity to a, and greater than a means from a to infinity. It implies that, it means, okay, if we have x square is greater than a square, then the value of x belongs from minus infinity to minus a, or a to infinity. So for all we'll use the union. So this is a to infinity, and this is also the vice versa. So we can use either way. Okay, the same thing if we have equality symbol over here. So at each end, like a and this minus a, this will be closed interval. So you can see over here, if x square is greater than equal to a square, then we can write it as x belonging from minus infinity to a union, this is minus a to infinity. So these are the inequality that we have to like keep it handy. Means whenever we are solving the problems on inequality, this will play a crucial role to get the solution. Whenever we are getting an expression of this kind, we can directly write the answer as by using these results. Now if we have inequality given like this, x square is greater than a square but less than b square, then in that case what will be the values of x? So let me try to break down into two inequality. Let's say a square is less than equal to x square, or x square is less than equal to b square. So from this inequality that we have discussed just now, x square is greater than a square, means from here you can find that x belongs from minus infinity to minus a. Minus a will be included because this is equal to less than, union a to infinity. And this one, x square less than b square, this will give us x less than b and greater than equal to minus b, or you can write it as x belonging from minus b to b. Now we have to look for now if we like just look into this, from this part we are getting x value from minus infinity to a, union a to infinity, and from here we are getting from minus b to b. So here this will be like a square less than x square, so this is and, okay, and x square less than b square. So keep it in mind one thing, whenever or is there means union, and if it is and means we have to go for intersection. So here from this part we are getting values of this much, and from here we are getting values of this much. It means from this and this we have to look for the common values of the real number. So we can identify it from this one. Let's try to understand it by using the line a square is less than x square, and we have x square less than equal to b square. It means if you just think of on a line, let's say I'm taking this as a origin O. So here if you're taking any point x on this number line, the square of that will be bigger than a square. It means if you are taking x over here, then either like distance of point x from origin is this much, then distance of point a from origin will be less than that. Okay, so here x square is greater than a square. It means what? Distance of x from origin is greater than the distance of point a from origin. The same here, we have b square greater than ax square, means distance of this point b is much bigger than the distance of x from origin, means it is somewhere like b is over here, right? So by looking into this, we can just draw this intervals on the number line and get the common region. It means if we are trying to write the numbers on number line, here this is origin. So if a is here, then B will be right of it. Okay, let me take it as B. So on the right, if this is A, so at the same distance on the left, it will be minus A. And if right, this is B, then from origin, so at the same distance on the left, this will be minus B. Now from this one, we are getting the region from B to minus of B, minus of B. But from this one, we are getting the value of x from less than minus a to infinity. Minus a to minus a means minus infinity included, minus infinity to minus a to minus infinity, and a to plus infinity, a to plus infinity. Now we need to look for the common in this region. If we are going to take the common, it means we need to look for, okay, this is B and this is A, so this is one of the common region, as well as here we are getting the common for both. So the solution set for this is nothing but x belonging from minus B to A. Here B also included, minus B also included, and A also included. So minus B to minus A, as well as from A to B. So union A to B. So this is also one of the direct result that you can remember like this. If we have given x square less than b square and greater than a square, then we can write it as like this: x belongs to b also included, a also included. So negative of b will be smaller than negative of a. So negative b, negative a, union a to b. Like the same way, if we have given inequality, like any of the inequalities, like only less than type or both are of less than type, then only we have to just replace this like close interval with open interval. So let's see here, we have x square is greater than equal to a square but less than b square. It means we can directly say that x is lying between minus b, because here open interval, so we have to use this bracket, minus b to minus a. Here equal to symbol, so we have to put close interval, then union again a to b, open interval, because at the end, this end, the inequality is only of less than not equal to. The same way, if we have this, so you can directly write, so x belonging from minus b to minus a, open interval, union open interval at a to close interval b. And this is also if both inequality is of less than, then both end will have open interval minus b to minus a, union a to b. So these are the important results that we need to like remember. Now let's come to this point. We have given an inequality and a is less than b, means x minus a into x minus b less than equal to 0, and here this a is smaller than b. It means a and b will be the critical point, and a will be on the left. A will be on the left because a is less than b. So from this you can draw the curve, and you will find that here positive, here positive, we are looking for negative. It means the values of x will belonging from a to b. So directly we can write like this also, or we can write this as x is less than equal to b or greater than equal to a. If it is less than only, then in place of this closed interval, we'll use the open interval. So you can answer this. So this will be nothing but if we have x minus a into x minus b less than 0 and a less than b, then this will be nothing but x belonging from open interval a to b, or we can write it as x is less than b and greater than a. If just opposite of this, means if a is bigger than b, then in that case it will be just opposite of this, means x will be less than a and bigger than b. Now this is the last result that we need to remember. Here these both are positive, means product of these two are positive. It means and a is less than this, so if you plot on this you can easily find, okay, this is a, this is b, and this region positive and this region also positive. Here this will be negative. We are looking for positive, it means the value of x is nothing but minus infinity to a, as well as this is closed interval, so this point will be included and this point will be also included. So x belonging from minus infinity to a, closed interval, union from b to plus infinity. Or in other way also you can write, like you can write it as x less than equal to a and greater than minus infinity, or x greater than equal to b but less than infinity. If we have only greater than symbol, then instead of this closed interval we just need to use the open interval. So here you can find this like you can write directly like x is belonging from minus of infinity to a union b to infinity. So these are the results that you just need to keep it in mind, and whenever you are finding such expression while solving the inequality, you just have to directly use this result. So these are the result I have mentioned over here, so that you have to remember. Or just if you practice, then you will have fair enough idea that, okay, whenever you are getting this, directly you can write this all expression. Now let's move to solve few more questions on the inequality by using all the result that we till now got from by solving the questions, as well as by doing all these Wavy curves and properties of inequality. So here we have given this inequality. You just need to think of we can directly use the Wavy curve method to solve this or not. So for that, first thing we have to check for the sign of the variables over here. So x is like positive, here x is positive, here x is also positive, so no need to worry. Just try to find the critical point by equating each factor equals 0. So by equating x minus 2 0, you will get x is equal to 2 at a critical point. By from this you will get x3, from this you will get x is equal to minus 1. Now plot all these points on a number line in ascending order. So minus 1, 2 and 3. As this whole expression is of positive sign, so we just have to start making curve from above the line and it will pass from 3. Now whether this point 3 will be included or not will be decided by this inequality symbol, which is only greater than type, so this will not be included, means we have to make a hollow circle. Now from this we have to check the power of this factor. Power of factor is even, so this curve is positive, so it will not change the sign, it will continue like positive to the next critical point. So here we got again plus. Now we got 2, so look, the factors x minus 2 is power 1, means odd power, so this will change the sign from positive to negative. And over here x is equal to minus 1, for this factor power is odd, so again it will change from negative to positive. Now to look for the roots, we have to just check the inequality, which is of greater than 0 means positive, so we have to take all the positive region and take unions of that. So here this is less than minus 1, so it is nothing but minus infinity to minus 1. All will be open interval because none of the point is included. So now here union, then from 2 to 3, union 3 to infinity. So now let's move to the next session. So here we have one more questions. So for solving this, first we have to look for the coefficients of the x. Here, okay, this is linear. First thing is all are linear, so no need to worry. If it is not linear, then we must have to go for factorizations. Okay, so x linear, all are x linear, but here x positive, but here x is negative. So we need to take minus common out. So 7 minus x power 3, if we are taking minus 1 common, means minus 1 power 3 is out, and then this will be x minus 7 to whole power 3. Then negative of minus 1 to power 3 will be negative 1. So this will be negative of x minus 7 to whole power 3. So this whole expression will become nothing but negative x plus 2 and 2x minus 3 whole power 5, and this will become x minus 7 power 3. This minus I have taken over here because multiplication of all number means that negative sign will come over here. Then this will become 2x plus 9 whole power 2 less than equal to 0. So as this expression is negative, so if you are not going to change the this to positive, then the curve will start from below the line. So to avoid this all confusion, just multiply both side by negative 1, then by multiplying with negative 1 this expression will be positive, and on the right we have 0. 0 into any number is 0. By doing multiplication with negative sign, this inequality sign will change, so this will become x plus 2, 2x minus 3 power 5, and x minus 7 to whole power 3, 2x plus 9 whole square greater than equal to 0. Now we need to look for this inequality. So find the critical point over here. So by equating this to be 0, we'll get x is equal to minus 2. From here we'll get 3 by 2. From here we'll get 7. And here we'll get minus 9 by 2. So these are the critical point that we need to plot on a line in ascending order. So here is the line, and the smallest among all is minus 9 by 2. Minus 9 by 2, minus 2, and then 3 by 2 and 7. So first thing is this is greater than or equal to symbol, so all the point will be included. So dark it all this point so that you should not miss this point while writing the interval. Now if you start making a curve from the right, because this expression is not positive, so from above line we have to take. Now for 7 factor is this one power is odd, so it will change from positive to negative. 3 by 2 came from this one, again power is odd, so it will change from negative to positive. Now minus 2 came from here, this power is also odd number, so again it will change from positive to negative. Now this factor is having even power, so now sign will not change, it will continue like negative. Now we need to look for the region where this whole expression is greater than 0, means positive. So positive region is from minus 2 to 3 by 2 and then 7 to infinity. So the solution for this is set of all x as this point are included, so close interval minus 2 to 3 by 2 union 7 to infinity. So now we have another question which seems to be very very large expressions, but this is quite simple. Just you have to focus on the main thing, each factor should be linear, coefficient of the variable should be positive. So if you start looking into the factor, each factor is linear because x power 1, x power 1, x power 1. This whole expression is power 2015 and something. Okay. And here x is positive, 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 positive. In the denominator also positive. Now this is greater than equal to 0. So first try to find the critical point by equating all of these factors equal to 0. So let me start from the numerator. So by equating this to 0, you will get x is equal to 2. From here we'll get minus 1. It will give us 1 by 2. And from here this is minus 4. X bar something means this is nothing but x minus 0. So from here we'll get 0. And x minus 3, 0 means 3. And from here minus 2. We got all the critical points. We just need to plot this critical point on number line in ascending order. So first one is the smallest number is minus 4. So here minus 4, then minus 2, then minus 1, 0, and then 1 by 2, 1 by 2, then 2 and then 3. Now, as this inequality is of greater than equal to, it means all the critical point of the numerator will be included. So look for the critical point. This is 2 minus 1, 1 by 2 and 4 will be included. So target minus 4, 1 by 2, 2 and minus 1. So except 0, 3 and minus 2. Because these are the critical point of denominator, so it should be a hollow circle. Now start making curve from right, so here to here positive. Now this factor 3 is from here odd number, so it will change from positive to negative. Now 2 came from this one, so as this is even number, so curve will not change its sign, it will continue like this. Now 1 by 2 came from here, which is odd number, so it will change the sign. Now 0 is this one, which is even power, so it will not change sign, it will continue in the same sign. Okay, now minus 1 came from here, odd power, so it will change sign from positive to negative. Then minus 2 came from here, so this is also odd, so it will change from negative to positive. And minus 4 came from here, which is even, so it will not change its sign, it will continue like this. Now as this expression is positive, it means we need to look for all the positive region. So here this is like positive from minus infinity to minus 4 as well as minus 4 to 2. So you can directly say that okay, this is nothing but x belonging from minus infinity to minus 2, because minus infinity to minus 4 and then minus 4 to minus 2 is nothing but union of these two is minus infinity to minus 2. So we can directly write this, and then further we need to look for the positive region. Here it is, so union close interval at minus 1, so minus 1, 0 and again. So from here this 0 is not included, right? So we'll take again union from 0 to 1 by 2 closed over here, and then from 3 to infinity, so union 3 to infinity. So this way we have to solve the inequality problems. Now here in this discussion, we need to find the set of all value of x for which 2x square plus 5x plus 2 less than 0. So here this is a quadratic, so we need to factorize it, or we need to split this into the product of two linear factors. So for that, what we need to do is, as you can see, x squared term is there, so it means we can make it either a plus b whole square format or a minus b whole square format. First take 2 common to make the coefficient of x squared to be 1, so we'll get it as x squared plus 5 by 2x plus 1, which is less than 0. Now as we got this expression, so once we are like dividing both side by 2, then there won't be any change in the inequality sign because both are positive. So here, okay, this will become x square plus 5 by 2x plus 1 less than 0. Now try to make it a perfect square. If we can write it as x square, so this is x term, it means this must be 2ab format, so we need to multiply by 2 and divide by 2, and this is 5 by 2x plus 1 less than 0. So here this will become x square plus 2 times of 5 by 4x plus 1 less than 0. So if we see, this is a square, this is 2, and this is a, and this b means b square term we are missing over here. So just add b square term and subtract, means add 5 by 4 square and subtract. So by doing that, we'll get 2 times of 5 by 4x plus 5 by 4 square, and then minus of 5 by 4 whole square plus 1 less than 0. So now these three terms will give us x plus 5 by 4 whole square, and by simplifying this will become 25 by 16, and it is plus 1, so 25 by 16 plus 1 less than 0. So once further we'll simplify this, we'll get it as minus 16 plus 25 is nothing but minus of 9 by 16, which is less than 0. Now as here I can use, you can see that this is 3 by 4 whole square, so we can write it as 5 by 4 whole square minus 3 upon 4 whole square less than 0. If you want, if you see, this is nothing but of the format ax square minus a square less than 0, means if you are like shifting this term to opposite side, this will become nothing but x plus 5 by 4 whole square less than 3 by 4 whole square. So it means if we know if x square is less than a square, means x value lies between a and minus a. So from there we can clearly get the values of x plus 5 by 4 lies between minus 3 by 4 to 3 by 4. It means x plus 5 by 4 less than 3 by 4 and less than, I mean greater than 3 minus 3 by 4. Now we want the values of x, so 5 by 4 over here, if we are subtracting everywhere, then this will become 0 and this will become, let's see, this will become minus 3 by 4 plus 5 by 4, and okay, means we are subtracting over here, means minus of 5 by 4 and it will be x, here 3 by 4 minus 5 by 4. So when you simplify this, it will become minus 8 by 4 means nothing but minus 2, and this is like 3 minus 5 is minus 2 by 4, so minus 2 by 4 means minus 1 by 2. So the value of x is nothing but from minus of 2 to minus 1 by 2, open interval at each end. So this is our solution for this particular question. Now let's see few more questions and then we'll now here in this question, this is the same question but the change in inequality sign. So once you factorize this, then you will get x plus 5 by 4 whole square. So here this you will get after factorization x plus 5 by 4 whole square greater than 3, I mean 3 by 4 whole square. So 3 by 4 whole square. So if you just recall the important result that we have, like if x square is greater than a square, then the value of x will be from negative infinity to negative a union a to plus infinity. So it means from this we can say that okay, the value of this x plus 5 by 4 is greater than minus infinity less than minus 3 by 4, or x plus 5 value is greater than 3 by 4 less than infinity. So once you solve this, means you just have to subtract 5 by 4 over here, means minus infinity minus 5 by 4. So here plus 5 by 4 minus 5 by 4 will be 0, means this will be x, and on the right we will get minus 3 by 4 minus 5 by 4. So from very large number, if you are subtracting minus 5 by 4, so again this both are negative sign, so this will give back again very small number, negative infinity. And here once you solve minus 3 5 is minus 8 by 4 means minus 2. Same over here, if you are going to subtract both side 5 by 4, then you will get 3 by 4 minus 5 by 4 and x, 5 by 4 minus 5 by 4 is x, and from infinity you are subtracting 5 by 4, which is very small number. But if you are subtracting from very bigger number, means that will be, there's no impact changes in that, we don't know, this is very big number, right? So infinity minus some given non-number will be always infinity, so this is infinity. So this is 3 minus 5 is minus 2 by 4 is again minus 2 by 4 is nothing but minus 1 by 2, which is less than x, and x is less than infinity. So by combining these two, we can say that x value belonging from minus infinity to minus 2 union minus 1 by 2 to infinity. So this way we can solve, like whenever we have quadratic expressions, then always go for like factorization of that, write it as a product of prime. Most of the time, like you can find that squaring of the number, like a plus b whole square format, or a minus b whole square format will work out over here. So now let's see, in this question we need to find the set of all A's for which this particular inequality is satisfied. Okay, so here the same thing, we need to just make one side to be 0. So just like subtract this 1 upon x plus 1 either side, then right side will become 0 and left side will be 2x upon 2x square plus 5x plus 2 minus 1 upon x plus 1, which is greater than 0. Now here denominator is 2x square plus 5x plus 2. So if you think of this number, take the LCM of the denominator, so it will become x plus 1 times of 2x squared plus 5x plus 2. Then this will become 2x into x plus 1 minus 1 into this expression, 2x squared plus 5x plus 2 less greater than 0. Now once we simplify this, numerator will become 2x square plus 2 minus 2x square minus 5x minus 2, and denominator will be x plus 1. Once we factorize this 2x square plus 5x plus 2, like you can see, this is the last example, then we'll get it as x plus 5 by 4 whole square minus 3 by 4 whole square. So this will become x plus 5 by 4 whole square minus of 3 by 4 whole square. Okay, so this is the expression. If you see the numerator, 2x square got cancelled, plus 2 got cancelled, minus 2 got cancelled, we left with minus 5x in the numerator. So this will become minus 5x divided by x plus 1, and this is a square minus b square format, so we can just use the identity. This will become x plus 5 by 4 minus 3 by 4 means 5 minus 8 2, so 2 by 4 means x plus 1 by 2. This will become x plus 1 by 2, and when we are going to add these two numbers, then 5 3 8 by 4 means x plus 2, so x plus 2, which is less greater than 0. So we got this inequality. We need to just go for finding the critical point. So for numerator, see here, coefficient of x is negative, so just like divide positive by minus 5, then this will give us, like by dividing minus 5, it will become x upon x plus 1 and x plus 1 by 2 x plus 2. Inequality sign will change because we are dividing by negative 5, so this will be less than, and 0 by 5 is 0. Now from this we can find the critical point. So numerator critical point will be 0, from denominator it is minus 1, from here minus 1 by 2, from here minus 2. So we need to just plot this point in an ascending order on a number line and then draw the Wavy curve. So over here we have minus 2, minus 1, minus 1 by 2, and 0. So if we are drawing a Wavy curve from the see, we can see that each factor having power odd, so it will start from positive and alternately it will change the sign. So like this will get the Wavy curve, and here positive, 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 this is negative, negative, as this expression is negative, so we need to look for the negative interval, and this is less than, so there is no critical point included in the solution, so we have to just take it as a hollow circle. So now from here we can say that the solution of this inequality is x belonging from minus 2 to minus 1, so minus 2 to minus 1 union minus 1 by 2 to 0, minus 1 by 2 to 0. Now, in this question, we need to find the interval where this function is negative or positive. So a function is negative or positive means we have to like write it greater than 0 for positive and for less than 0 negative, because no, 0 is not neither positive nor negative. So let me just go for like positive. So for positive, this will become x minus 2 power 5, x plus 5 power 4, x minus 3 power 3. divided by x minus 1 power 3 x plus 2 power 5 greater than 0. So now here each of the factors in numerator and denominators having linear in x as well as positive x coefficient. So we just need to go for finding the critical point. So from each of the factor, if we are equating it with 0, we'll get from numerator, from this one will get 2, from this one will get minus 5, and here 3. So 2 minus 5 and 3 are the critical points for the numerator, and for denominator by equating it 0 we'll get 1 and minus 2. So 1 and minus 2. Just plot this point in ascending order on a line. So here it is, a smaller one is minus 5, minus 2, and 1, 2 and 3. Now as this is positive, so we'll start from like curve from above the line, as well as this is only greater than type, so none of this critical point will be included in the solution, so we can like mark it as a hollow circle. So this will come over here and look for the factors for which 3 is the critical point. So it is x minus 3. Its power is odd, so it will change the sign from positive to negative. Again check at 2, so here also even odd power, so it will change from negative to positive. At 1 again power is odd, so it will change from positive to negative. Then at here also negative to positive. And for x minus 5 means for x is equal to minus 5, this is the factor for which the power is even, so it will not change the sign, it will continue to positive. Now we got the critical point and the interval where the particular expression is positive and negative. So for positive the intervals are minus infinity to minus 5 and minus 5 to minus 2. So if you are taking union of minus infinity to minus 5 and minus 5 to minus 2, it will give us directly minus infinity to minus 2. Okay, because this region and this region, if we are going to take, if we are going to take the union of this region and this region, then this will become whole region. Okay, now union of this 1 to 2 and then union 3 to infinity. Now for negative value means this will be less than. For negative value we have to just look for the interval where it is negative. So for negative x is minus 2 to 1 union 2 to 3. Okay, so let's see this example. This is one of the very good examples till now that we have discussed. So here we have given a square root of negative x square plus 10x minus 16 is less than x minus 2. So here a square root is there, so whenever a square root is there, always go for like domain of the expressions. Okay, so first thing is, if you look on to the left side, means a square root will be defined only if the expression inside will be either equal to 0 or greater than 0. So it means if it is equal to 0, means this expression is 0, means the square root will be 0, then the right expression will be x minus 2 will be bigger than 0, and from here you can find that x value will be greater than 2. So this is one result we got over here. Now if x is greater than 0, then this will be obviously positive and the square root of number will be positive, right? So we have to check that, okay, what values of x will satisfy over here. So just go for the domain of this expressions. If it is defined, then this inequality will be defined. So first let me check the domain for this. So domain for this is nothing but negative x square plus 10x minus 16 should be greater than equal to 0. So here, once this is a quadratic expression, so just we have to factorize it, but here coefficient of x is negative, so multiplying both sides by negative 1 will reward the symbol of inequality, and each of the expression, each of the term like sign will be changed from here negative x square to positive, then this is negative 10x and positive 16 less than equal to 0. Now we just have to factorize this. So by splitting the middle term, we can write it as minus 2x minus 8x plus 16 less than 0. So from here we will get x minus 2 into x minus 8 less than equal to 0. If you just recall that we have already seen that if any of the inequality like this means we can directly say that okay, here this is less than equal to, right? So from here we can say that okay, we have seen x minus a into x minus b if less than equal to 0 means x value will be less than equal to b but greater than equal to 8. So from here we can say that okay, x value is less than equal to 8 but greater than equal to 2. It means we are getting the values of x between 2 to 8, but from the first inequality, first condition, we are getting the value of x to be greater than 2. In this question, we have to look for the integral values of x, which by combining this two inequality, that should be greater than 2 but less than 8. So by combining these two, x less than equal to 8 greater than equal to 2, if we are taking the intersection of these two, as 2 is not common in both and values of x is bigger than 2 but less than equal to 8, so from this we can get it like x is from 2 to 8. 2 will not be included, okay, because if you see just like this, we have given bigger than 2 and second is given from 2 to from 2 to 8. So if we are going to take the common, so here this point is included because it's continued, but here this point in this interval is included but in this interval is not included. So by taking common, what should have the same thing. So here because of this point will not be included. Okay, so we are getting the values of x from bigger than 2 but less than 8. So in that we have to just look for the integral value. If we see from 2 to 8, the integral values are nothing but 3, 4, 5, 6, 7 and 8. So from here we are getting how many values of x? 6 values. So is it a solution? So we have to just check once again this particular inequalities, that if whatever be the values of x is here is bigger than 2 means this will be positive, right? And also for x bigger than 2, this expression is also positive, means left side also positive, right side also positive. So in inequality we know that if x less than a is having both sides are positive, so by squaring both sides there is no change in the inequality sign. So by using the same things we are going to like further simplify this by squaring both sides. So if we are going to square both sides, we'll get it as left side as minus x square plus 10x minus 16 less than x minus 2 whole square. So as if you are squaring here means this square and square root cancel and this side will be a square of this. So now further simplify this inequality, we are getting like x square plus 10x minus 16 and on the right side x square minus 4x plus 4. So bring all the terms on one side. So here this will be 0. I'm just like shifting all this to other side, x square, and by adding x square it will be 0. Here x square means 2x square. Now minus 4 and minus 10 is minus 14x plus 4 plus 16 is plus 20. It means from here if you see 2 is common means x square minus 7x plus 10 is greater than 0 means x square minus 7x plus 10 is greater than 0. Once we are going to factorize this, we'll get it as x square minus of 2x minus 5x plus 10 greater than 0. So here we'll get it as x minus 2 into x and x minus 2 greater than 0 means x minus 2 into x minus 5 greater than 0. Again, if you just recall x minus a into x minus b greater than 0 means x value will be from minus infinity to a and x value is less than infinity to b. So by this you can directly write from here like this is nothing but x value is less than 2 greater than minus infinity, means x value is less than 2 greater than minus infinity, or x value is less than infinity but greater than 5. So as if you again see, this is result number 3. If you again see, the first result that we got is x value is from 2 to 8. So less than 2 is not at all valid. So this is not valid. So in this, bigger than 5 to 8 means from 5 to 8, and here we have 2 to 8. If we are going to take the intersection of these two, so here 5 to 8, here 2 to 8. So if we are going to take the intersection of these two, we'll get values from 5 to 8, means x value belonging from 5 to 8. 8 is included. So in this interval, this is the right interval where this particular inequality will satisfy. So from this we can say that between 5 to 8, the number of integral values are 6, 7 and 8, means there will be 3 integral values of x which will satisfy this particular inequality. I hope this is like clear, and you now will be able to solve the question based on the inequality. This is the questions I'm keeping it as for you people to like try it, then solve this and comment your answer in comment box. So we'll meet soon with some more topic in this inequality, like inequality involving modulus, inequality involving logarithms, and few more general type of inequalities. So stay tuned. If you like the videos, if you feel that this is like helping you in some of the way, then do like it, subscribe it, and share this with your friend too. So we'll meet soon in the next video. Bye bye.